In this video, we'll be taking a look at Maya's object structure and hierarchy. We'll start by creating a polygon sphere and taking a look at the attributes that make up this object. In the channel box, you'll see the most often used attributes, also known as channels. Those are the translate, rotate, and scale. If you click on the attribute editor tab, or if you press Ctrl A to toggle, you'll see multiple tabs in the attribute editor. The most often used attributes under P-Sphere 1 tab correspond with the channels or attributes that you see in the channel box. The translate, rotate, and scale are exactly the same. As soon as you create some different transforms for the objects, same values appear in both windows. Now I'll Control Z to undo those. And we'll check out P-Sphere Shape 1. This is the shape node, and it has attributes that have to do with the object's tessellation and controls over the actual geometry, the mesh itself. These attributes have to do with how the object renders out. Another tab is the Polysphere one. This is the creation node. It has attributes that have to do with the object's creation. Most notably is the subdivision. The axis and the height control the number of polygons that make up this object. Most objects that you create that are polygons, let's say we'll create a torus, will have some sort of creation options, such as radius, number, section radius, twist, and so on and so forth, that allow you to adjust how the polygons are arranged for that object. Going back to the sphere, I'm going to press F to focus my view on the selected object. I'm going to have control over how well tessellated or how many faces this object will have. It's important to set these numbers first when you create your object, because once you start editing your object, for example, if I start moving some of the faces around, if I go back to change the subdivisions, you'll see my model starts getting janky, which is an industry accepted term for when things go weird or wrong. So you want to make sure you've got your subdivisions set properly before you begin editing your model. So this is one of the first things you want to consider when you create a primitive to start modeling from, is to set how much resolution, how much faces you need for that object to do your model. Even though the node is still there, it will certainly go janky when you edit these numbers after creating edits on your model. The other inputs on this object are initial shading group and Lambert 1. These correspond to the default shader that is automatically assigned to every object that comes into Maya. The ones you should really be taking a look at are, again, the creation options as well as the channels that tell you where the object is in space and its orientation and scale. Now I'll press delete to get rid of that sphere, and I'll go ahead and create another polygon sphere. What we're going to do is take a look at the components that make up the sphere. If I right click on the object, I'll get this marking menu, which allows me component selection. For a polygon, I have vertex or vertices, I have faces, I have edges. These are the components that make up a polygon. One polygon is surrounded by edges. Edges are shared between polygons. Polygons are also known as faces. At the intersection of edges are vertices, or a single vertex. All of these are editable to create different shapes. To exit component mode, simply right-click and go to Object Mode and select your object. While in component mode, you've got the ability to translate the component as well as rotate and scale using the familiar WER keyboard shortcuts to access those tools. Now let's take a look at NURBS sphere and take a look at the components that make a NURBS what it is. Let's go back into object mode. We'll move the polysphere out of the way. We'll go to the surfaces menu and click on a NURBS sphere. Now, a NURBS sphere has a different surface type than a polygon. It's made of non-uniform rational B-spline. This surface has components as well, except slightly different. We have control vertex, we have isoparms, we have hulls, and these control the shape of the object. Much like vertex selection controls the shape of a polygon at a very linear fashion, a NURBS CVs or control vertex controls the shape of the object in a smooth fashion. You'll notice that the CVs are actually not connected on the actual surface of the sphere, where the vertex is actually on the polygons. The CV, because of the mathematics that are required to make a smooth surface, CVs are not required to be physically on the surface. They interpolate to give you a smooth result when they're moved around. The lines that run on a NURBS surface are called isoparms, and there is an infinite amount of isoparms on an object. You get to see the visible ones in wireframe, but isoparms can also be selected anywhere on the surface itself. Isoparms are not directly editable like CVs are, or like edges are in a polygon. Instead, isoparms are generated by the positioning of CVs. There are many modeling functions that will use isoparm selection, but again, they're not directly editable like edges or faces or CVs are. Hulls are basically rows of CVs, which makes editing lots of CVs together easier to manage. Now let's take a look at Maya's object hierarchy structure, a very powerful feature in Maya. We'll go to File, Open Scene, and you'll want to navigate to the Chapter 2 folder of the files. In the Chapter 2 folder, you'll find planets start.mb. We'll go ahead and open that scene, and you'll see an arrangement of planets, including poor little Pluto, which is no longer considered a planet, arranged around a big gray sun. Now, if we take a look at these planets, these spheres, here's Earth. Hey, look, I can see my house. What the purpose of this scene is to take a look at how planets will orbit around the sun, but also have moons that orbit around the planets and go with the planetary orbit as well. Now we'll go ahead into the window menu and open up the outliner, arguably the best tool for Maya hierarchy. Here you can see an outline form of all the objects that are in the scene, all the planets, a ring here for our little friend Saturn, and all the moons that surround these planets. Now we've just gone ahead and given almost every planet just 2 moons. The idea of this exercise is to be able to give each planet, like the Earth here, a rotation for its own orbit, and also give it a chance to orbit around the sun itself along with its moon. And we'll be using grouping to make that happen. So first things first, we will set some keyframes for the Earth. Let's set my animation range here. Let's go to 48 frames. We'll go to frame 1. And I'll go ahead in the channel box. I can select the rotate attributes or channels, right click and hit key selected. I can also press Shift E on my keyboard. I'll go to the end of my range and I'll hit E for rotate, and I'll give it a bit of a spin. I can also type in a number here. Let's go negative 843, just a number out of the air. Go ahead and right click on rotate Y and hit key selected. I've got a rotation on the planet. That gives us the day and night. Next thing I'm going to want to do is rotate or orbit the planet around the sun. Now what allows me to rotate the planet about its own axis is the pivot point. The pivot point is automatically at the center of the geometry, at the center of the sphere. What I need to do is essentially create another pivot point that is in the center of the sun. And to do that, I will go to Edit, Group. What that does is it creates a group node called Group 1, which has the Earth as its child. This is the parent node, and this is the child node. You'll notice that Group 1 automatically has its pivot point at the origin of the scene, which just so happens to also be at the center of the sun. We'll go ahead and double click in the outliner to rename this node as Earth Orbit. Now I have the ability to set keyframes for Earth Orbit's rotation. I'll do so at frame 1, right click, key selected. I'll go to frame 48 and I'll press E for rotate, and I'll give the Earth a little bit of a spin around the sun. Let's go ahead and bring it almost all the way back. And here I'll click on rotate Y because that's the only channel that's being changed. And I'll hit key selected as well. If I scrub my animation, I will have not only rotation on the planet itself, but also an orbit around the sun. Now, my next task is to make sure the moon can orbit around the Earth. Using the same principle, I need to add a group to the moon by going to Edit, Group. That places the pivot point in the center of the sun, but I need it in the center of the Earth. If I press and hold the D key, I will gain access to being able to move the pivot point for that selected object. Now keep in mind, I'm on the group node when I move the pivot point, not on the moon itself. I'm going to double click and name this moon, and double click here and name this moon orbit. And these are the 2 pivot points I have to work with now. Now that I have the moon orbit pivot point around where the Earth is, I will set keyframes for the rotation as well. Right click and key selected. And you'll immediately see that I'm going to have a little bit of a problem rotating moon orbit because the Earth is already left. If I press E, my pivot point is still where the Earth used to be. Well, that's very easy to fix. I'll go back to frame 1 to place the relationship of these two objects back in sync. And I'm going to go to moon orbit, and I'm going to parent it under Earth orbit by middle mouse clicking on moon orbit and dragging it to outline Earth orbit, like so. You'll see there's a difference between a single line that will merely place the entry in the outliner as opposed to the double line, which will actually group that object. Now I've got this hierarchy where Earth orbit not only controls the Earth, but also controls moon orbit. If I scrub my animation, you'll see that the moon is now rotating along with the Earth's orbit. If I go back to moon orbit, I'll be able to set some animation for the moon to orbit around the Earth. I'll have it go around a little bit, and then I'll right click on rotate Y and key selected. If I run my animation now, I'll have a nice planetary movement. Now, if you open the planets continue file, you'll see many of the same objects that are already grouped, and you'll be able to take a look at how the animation here works and how the groupings of these planets have to work out to get this animation. Also gives you a chance to use this as a template to finish off the other planets and moons and get them rotating about the sun. In this video, we took a look at Maya's object structure in the outliner, as well as object and component mode for each of these objects.